This video is looking at the learning target. I can solve an equation with a rational exponent. When you have an equation that contains a power with a rational exponent, you don't necessarily have to change it to radical form first, which you could do, but there's a little bit simpler way to deal with a rational exponent. When an equation contains a power with a rational exponent, first isolate the power, get the portion with the exponent by itself, and then raise each side of the equation to the reciprocal of the rational exponent. The reason we're raising it to the reciprocal is when you multiply reciprocals, for example, just as an example, 2/3 times 3/2, remember multiplying fractions, you just multiply straight across. This will give you 6/6, which reduces to 1. And we know that an exponent of 1, we don't have to write. It really doesn't change anything for our problem. And so that's what our goal is, to try to get that rational exponent to go to 1. But again, we have to raise both sides of the equation to that power so we can keep that balance. So if we look down here at some examples, our first one is 2x to the 3/4 power plus 2 equals 10. Well, step 1 is to isolate the power, get the part with the exponent by itself. So I'm first going to subtract 2 from both sides, and that gets me to 2x to the 3/4 power equals 8. Now that the power is isolated, I'm going to raise both sides of this equation to the 4/3 power. This will cause my exponents, when I multiply them, to go to 12/12 or reduce to 1. That will just leave me with 2x on this side. 8 to the 4/3 is really asking me to do the cube root of 8 and then raise that to the 4th power. And if you think back to our previous learning targets, the cube root of 8 is 2, and 2 to the 4th power is 16. And this is basically what you're left with, and then you would continue to solve for x. We would just divide both sides by 2, and we get an answer of x equals 8. If you look at something like example B, you have x plus 6 raised to the 1/2 power is equal to x. The power is already isolated. There are no other parts that I need to undo first. So I am ready to just raise both sides of the equation to the reciprocal power. Well, the reciprocal of 1/2 is 2, so I am going to square both sides. This gives me x plus 6 equal to x squared. Again, when you have an x squared and an x term, this is a quadratic equation, and the most common way that we will be looking at solving quadratics is to try factoring or possibly quadratic formula. This problem, I think, will be a good one to try factoring for. The first step to factoring is you do need to have one side equal to 0. I'm going to subtract x to move it to the other side. I'm also going to subtract 6. It's easier to factor if your x squared term stays positive. So we're now at 0 equals x squared minus x minus 6. And what I am looking for is, first, we always check for a greatest common factor. Since I have coefficients of 1, I do not have a GCF other than 1. I am now going to set up my factors, and I am looking for two numbers that multiply to give me -6 that will also add up to -1. And the two numbers that will do that are -3 and +2. -3 times 2 is -6, and -3 plus 2 is -1. To get your solutions, we are now going to set each factor equal to 0 and actually solve for x. X minus 3 equals 0, the solution will be 3. X plus 2 equals 0, the solution will be x equals -2. So this problem has two solutions. You should probably go back and make sure, since this was to the 1/2 power in the original problem, which is the same thing as square root, make sure that you don't have an extraneous solution here. Plugging in 3 plus 6, we absolutely can raise to the 1/2 power. And -2 plus 6 gives you 4. You can raise 4 to the 1/2 power and get a real answer. So both of those are solutions. We will keep both of them. Example C, again, just a similar process. Okay, you want to get the part with the exponent or the power by itself. I'm first going to undo 4 by subtracting 4. This 2 is not part of the power. It is not raised to that exponent. So I'm going to undo the 2 by dividing by 2. Now that I have isolated the power, I am going to raise both sides to the reciprocal power. Thus canceling out my exponents and just leaving me with x plus 2. 8 to the 2/3 is asking me to find the cube root of 8 and raise that to the second power. The cube root of 8 is 2, and 2 squared gives you 4. Again, that's going back to our learning goal number 1, looking at learning target number 1 and number 2. From here, again, I would just continue to solve for x, and I end up with an answer of x equals 2.